pH of solution example 2. We'll continue to do justice to pH until we all become master in any calculation involving pH. Let us see the question on the board. A glass cup of orange juice is found to have a pOH. They gave the value of pOH to be 11.0. They now ask us to calculate the concentration of the hydrogen ion in the solution. Don't forget all the formulas we have listed, and of which, since they gave pOH, let us use the formula that says pH plus pOH, which will give us 14. We are using this formula to get pH. Remember that the question gave us pOH. So it is when we have gotten pH that we can now calculate the hydrogen ion concentration. So there's no way we'll use the pOH they gave to get hydrogen ion concentration. Had it been it is hydroxide ion concentration, we will just solve straight. I hope we are following. Now, pH, let us substitute. pH equals pH plus pOH, they gave it to be what? 11.0 equals 14. Remember, pOH, they gave it to be 11.40. How do we get pH? pH equals 14 minus 11.4. Calculator will help us. If you press that in very, very well, you will get the pH to be equal to 2.6. To be equal to 2.6. This is the pH of the solution which has pOH of 4.0. Now, remember we have gotten the pH. It is from this pH now that we will get the hydrogen ion concentration. Don't forget the formula given by Sorensen in 1909 that says pH equals negative logarithm to base 10 of hydrogen ion concentration. This is the formula we will use now to get the hydrogen ion concentration as they ask us to find. So if you put this in very well, we are going to substitute the pH which we have gotten from this formula here and now solve for hydrogen ion concentration. So pH equals 2.6, which will give you negative logarithm to base 10 of hydrogen ion concentration. We can choose to rearrange this thing by negative logarithm to base 10 of hydrogen ion concentration equal to 2.16. And of which, you know mathematics, we let us multiply both sides by minus so that this minus will go off. If you multiply both sides by minus, you are going to get something like this. Equals minus 2.6. Minus 2.6. Now, how do we get hydrogen ion concentration? It is simply the hydrogen ion concentration equals the anti-log. Oh, this is simple mathematics. Anti-log of minus 2.6. How do we solve this? We are going to split minus 2.6 into 2. So we are going to split minus 2.6 into 2. So think of two numbers that when you add or subtract, you are going to get minus 2.6. Think of 0.4 minus 3.0. 0.4 minus 3.0 will invariably or probably give us minus 2.6. So this is what you will do maybe in your rough place, but it is this minus this is going to give us minus 2.6. So what we are going to do now, is to find the anti-log of 4.0 and also find the anti-log of 3.0. So if you press your calculator very well, you find out that the anti-log of 0.4 will give us 2.51 approximately. Give us 2.51. And the anti-log of 3 will give us 1,000, which is the same thing as times 10 raised to power 3. 1,000 is 10 raised to power 3. But don't forget that it has minus here. So you put minus here. So this is the answer to what they are asking us. Let me repeat it from this side. You truly understood how we got pH to 2.6. And we apply this formula in order to get hydrogen ion concentration, which we have done here. To get the hydrogen ion concentration, we are going to find the anti-log of this side, which is minus 2.6. I say that this minus 2.6, we're going to split it into two. Think of two numbers that when you add or minus, it will give you minus 2.6. And we say that that number is 0.4 minus 3.0. If you punch a calculator very well, you are going to get minus 2.6. So you are going to find the anti-log of this number and also find the anti-log of this number. The anti-log of this number gives you 2.51 times anti-log of 3 give you 1,000, which is 10 raised to power 3. How come the minus? This 3.0 has minus. That's why I raised that minus up. So the hydrogen ion concentration in this juice, orange juice, is simply 2.51 times 10 raised to power minus 3. That is the hydrogen ion concentration in a glass cup of orange juice that has a pOH of 11.4. You can go through that again as we take another example.